All right, let's continue on with Unit 1, Physical Properties of Matter. Today's discussion is going to be about volume and volume's role in the chemistry lab. Let's get a quick definition for volume. Volume is the total amount of three-dimensional space taken up by an object. And today we're going to look at the three different most common phases of matter that we'll be working with here on our planet, the solids, liquids, and gases. So let's look at a solid first of all and try to get an understanding as to how the solid we can measure the volume of a solid. So let's take a look at a cube. Here we go. There's our cube, and it's three-dimensional, so we can see that it has dimensions to it. And now let's think about measuring the volume of this, and we've all probably done this in a math class at some point in time. If we wanted to find the volume of the cube, I'm hoping that we remember the volume is length times width times height. Okay, so you can define those three dimensions any way you want. Let's say that's our height, let's say that's our length, and let's say that our width is right here. There's our W going back into the page. If we multiply those three together, we're going to get a volume. Now, one thing to be very, very headsy of here is that each one of those dimensions needs to be in the same unit. What I mean by that is if you're going to take a ruler and measure your cube, you got to make sure the length is in it. Let's just go with centimeters right now. You got to make sure that the width is in centimeters, and you got to make sure that the height itself is in centimeters as well. When you do that, if you punch that in your calculator, you come up with some type of number for the volume of this cube. At the end of the day, you're going to get a number, and you're also going to get a unit. And that unit for this solid is going to be, let me put that up here, that's going to be the centimeter cubed. Okay, that's going to be a centimeter cubed. So our unit for a solid is a centimeter cubed. That's one unit that we can use. So let's call our units right here. Units for solids, we'll see centimeters cubed. We'll also see meters cubed. Those are our two main units for solids. All right, let's move on. Oh, one thing I wanted to say about solids is that they're also measured indirectly. What I mean by that, they're measured indirectly. Sorry. What I mean by that is that you have to measure three different dimensions, a length, a width, and a height, in order to get the overall volume, and then you're actually going to have to do math with that. So you're not going to be able to just do a measurement and then get that volume. You're actually going to have to do some calculative work. So that's what I mean by measuring indirectly. All right, the second state of matter that we'll look at, liquids. All right, think about a liquid, the molecules being a little more spread apart typically. Liquids, their measurement is easier because they're measured directly. So we're going to use some tool to physically measure the volume of a liquid. And three tools that you'll use in class are the beaker, the graduated cylinder, and the volumetric flask. And which one you use depends upon the precision that you need. If you don't have to be very precise, if you're just looking to kind of get a certain volume, a beaker is fine. If you want more precision, you may move up to a graduated cylinder. And then if you want even more precision, you may move up to a volumetric flask. All right, so what are our units for liquids? In the sciences, we're going to use the metric system again. So the base unit for a liquid is a liter. Now, you all probably have a pretty good visualization of what a gallon is. You can visualize a gallon of milk, maybe not a liter. So to give you some help, the next time you come into class, take a look at the water bottle that I drink out of. That is 1 liter. Okay, that's 1 liter. You need about 4 of those to make up a gallon. All right, so that might give you a good visual. We don't use the liter a whole lot in class because that's a lot of stuff. More often than not, we use something called the milliliter. All right. So a milliliter can be measured using a graduated cylinder, and that you see here on the page. And you'll notice the graduated cylinder tells you the measurement. Okay, right there you see milliliter. And now, while I have this picture up here, let's talk about how do we read a graduated cylinder. we always want to read from the bottom of what's called the meniscus. So every time we put a liquid inside of a graduated cylinder, especially water, it's going to make this little bowed water level. You don't want to read the top, you want to read from the bottom of that meniscus. Okay? And then that volume reading is going to give you milliliters. And we're going to discuss a little bit later this week how accurate we can be with this particular tool. Like, can we call this, 19.3 milliliters? Can we call this 20.42 milliliters? Like, what decimal place can we go to? We'll get into that later in the week. All right, so that's for liquids. So the third state of matter, and hopefully you're familiar with all these states of matter, are gases, obviously. Now, gases traditionally fill the container that they're in. So if I have that same box that I talked about on that first slide, here's my cube, and that cube was empty, and it was a very thin-walled cube, and I filled it up with gas, let's say helium, the helium would totally fill that cube. It wouldn't like corner itself into one corner. It would totally fill the cube until the whole cube was filled with helium gas. And even my little coloring here is not giving you a very good example because there's white spaces. So let's understand that the whole cube itself would be filled. All right, so the volume of the container is actually going to equal the volume of the gas. So if our container had a volume of 15 centimeters cubed, the gas would have a volume of 15 centimeters cubed. All right, so understanding that, we should know that the units for volume are the same as solids. So centimeters cubed, I think I also said meters cubed. So that's a quick rundown of volume. I want to leave you with two questions to ponder. Number one, I want you to think of, can the volume of a substance change even though the mass stays the same? Let's think about that. Can we change the volume of the substance even though the mass stays the same? And then number two, do you think there's any relationship between the volume in milliliters and the volume in centimeters cubed of a substance? All right, think about those things for tomorrow.